Hello friends, this is the last exercise for the M2 11th standard. That is the second exercise 9.2. Only the remaining part is the miscellaneous exercise of the remaining chapters. Now we'll start the exercise 9.2. Rules of differentiation. There are the rules for the differentiation, that is the derivative of sum of the functions. म्हणजे दोन फंक्शनची जेव्हा टोटल असेल तेव्हा त्यांचा डेरिव्हेटिव्ह कसा काढायचा या संदर्भातला रूल. इफ u and v are the differential functions of x means what? U and v are differential functions of x such that u and v are differential functions of x means u is equals to x square, u is equals to sin x, e is equals to e raised to x, v is equals to tan of x. These are the differential functions of x. And y is equals to u plus v, then dy by dx is equals to du by dx plus dv by dx. हा रूल आपण आता प्रूव्ह करणार आहोत. Now I am writing this proof by giving the numbers to each step. That is a given y is equals to u plus v, where u and v are differential functions of x. This you have to write this line. Y is equals to u plus v. That is there are the sum of the two functions. That is a u and v. These are the two functions of the variable x. Now next is, let delta u, delta v and delta y be the increment in u, v and y respectively. Now you will say that what is the delta u, delta v and delta y? तर हे स्मॉल चेंजेस असतील, स्मॉल इन्क्रिमेंट असतील. कोणामध्ये असतील? u मध्ये असेल, v मध्ये असेल आणि y मध्ये असेल रिस्पेक्टिव्ह. Therefore, for each and for every theorem we have to write this type of the dialogue. I will repeat for the next theorems also. Therefore, these are the basic lines, that is the delta u, delta v, delta y be the increments in u, v and y respectively. Means small change, means small increment. Now next, corresponding to the increment delta x in x. Now next line is, that is delta u, delta v and delta y be the increments in u, v and y respectively. Corresponding to the increment delta x in x means u, v and y. These are the functions and the variable is x. Now next, y is equals to u plus v. Therefore, there is a small change in y. म्हणजे y मध्ये जर थोडा बदल झाला, y plus delta y. At the same time, u आणि v मध्ये देखील थोडा बदल होणार आहे. Therefore, u can be written as u plus delta u plus v plus delta v. Therefore, now this can be again written as delta y is equals to u plus delta u plus v plus delta v minus y. But what is the value of y? Y is u plus v. We will substitute, cancel it. That is a delta u plus delta v. We will separate it. What I had done here, that is a delta u and the delta v is here. Plus this is u and this is v is here. Minus y as it is. But what is the value of y? Y is equals to u plus v. Therefore, u plus v plus u plus v minus u plus v get cancelled. And that's why delta y is equals to delta u plus delta v. Now next step is dividing on both sides by delta x and take the limit as the delta x tends to 0. Taking the limit as delta x tends to 0, then we get delta y by delta x. Limit delta x tends to 0. Limit delta x tends to 0, delta u plus delta v upon delta x. Now we will separate it. Therefore, limit delta x tends to 0, delta u by delta x as delta x tends to 0 plus limit delta x tends to 0, delta v upon delta x. This we treat as the number a. I had given the number a. Now u and v are differentiable functions of x, and limit delta x tends to 0, delta u by delta x is equals to du by dx, and limit delta x tends to 0, delta v upon delta x is equals to dv by dx. म्हणजे u आणि v यांचे व्हेरिएबल काय तर x आहे. u and v are differential functions of x, and limit of delta u upon delta x as the delta x tends to 0 is du by dx, and limit delta v upon delta x as the delta x tends to 0 is equals to dv by dx. Therefore, the limit on the RHS exists. RHS च्या a या बाजूकडे delta u by delta x plus delta v by delta x limit on the RHS exists, and that's why limit on LHS is also exist, and hence limit delta x tends to 0, delta y upon delta x is equals to dy by dx. Hence, dy by dx is equals to du by dx plus dv by dx. हे रूल तुम्हाला लक्षात ठेवण्यासाठी 2-3 वेळा तुम्हाला ते लिहावे लागतील आणि मगच तुमच्या ते लक्षात येतील. Now the corollary. We have taken only the two functions, that is a u, v, and suppose that if we take the three functions, that is u, v, and w, are differential functions of x, then y is equals to u plus v plus w, then dy by dx is equals to du by dx plus dv by dx plus dw by dx. In general, जर समजा आता 3 असतील तर आणि 3पेक्षा जर जास्त असतील सम मध्ये यांची बेरीज असेल, then u1, u2 up to the n are the differential functions of x, then the rule can be written as dy by dx is equals to du1 by dx plus du2 by dx plus du3 by dx, and in this way. Now the some illustrative example. First is if y is equals to x raised to 3, 3 raised to x, and 5 raised to 4, then dy by dx is equals to, that is a ddx of x raised to 3 plus ddx of 3 raised to x plus 5 raised to 4. आता x raised to 3 चा डेरिव्हेटिव्ह जर आपल्याला काढायचा असेल तर ही पॉवर पुढे घेणार 3 into x raised to 3 minus 1. Therefore 3x square, and derivative of 3 raised to x. मग कोणता फॉर्म असणार तो a raised to x, आणि a raised to x चा डेरिव्हेटिव्ह किती a raised to x into log of a. And what about the 5 raised to 4? 5 raised to 4, this is the constant quantity, and the derivative of constant is 0. Now see this. Here is, that is the derivative of 3 raised to x raised to 3 is a 3x square. म्हणजे ही पॉवर पुढे घेणार आणि त्या पॉवर मधनं एक मायनस करणार, म्हणजे आपल्याला किती मिळेल 3x square. डेरिव्हेटिव्ह ऑफ 3 raised to x म्हणजे काय, डेरिव्हेटिव्ह ऑफ a raised to x. a raised to x चा डेरिव्हेटिव्ह किती a raised to x into log of a. तसंच इथे 3 raised to x into log of 3 and the derivative of that is a 5 raised to 4. This is the constant quantity and hence its derivative is 0. Therefore dy by dx is equals to 3 raised to x 3x square plus 3 raised to x into log of 3. Number 2, if y is equals to cot x plus e raised to x plus log x. Now what is the derivative of cot x? आता मात्र तुम्हाला सर्व डेरिव्हेटिव्ह माहिती पाहिजे. या पहिल्या एक्सरसाइज मध्ये सर्व डेरिव्हेटिव्ह बाय युजिंग द फर्स्ट प्रिन्सिपल मी प्रूव्ह करून दाखवले होते तुम्हाला. द डेरिव्हेटिव्ह ऑफ द cot x is minus cos x square x. Derivative of e raised to x is e raised to x and derivative of log of x is 1 upon x. Now see this here. ddx of cot x plus e raised to x plus log x. And that's why derivative of cot x is minus cos x square x. Derivative of e raised to x is e raised to x. And derivative of log of x is 1 upon x. Now the next theorem. The derivative of difference means y is equals to u minus v. म्हणजे दोन फंक्शनची काय असणार तिथे वजाबाकी असणार आहे, सबट्रॅक्शन असणार आहे. If u and v are the differential functions of x such that y is equals to u minus v, then dy by dx is equals to du by dx minus dv by dx. मधलं साइन जसं तसं ठेवणार आणि या दोघांचे डेरिव्हेटिव्ह विथ रिस्पेक्ट टू आपण फाइंड आउट करणार. Therefore, proof. Let delta u, delta v and the delta y be the increment in u, v and y respectively corresponding to the increment delta x in x. हा प्रत्येक थेरम साठी फिक्स असा डायलॉग असणार आहे. Let delta u, delta v and the delta y be the increments in u, v, y respectively corresponding to the increment delta x in x. Y is equals to u minus v. And there is a small change in y. At the same time, respective changes in u and v are also. That is a y plus delta y is equals to u plus delta u minus v plus delta v. Therefore, delta y is equals to u plus delta u minus v plus delta v minus y. Now, separate the terms u minus v. Add मी या प्रकारे लिहिले u minus v plus delta u minus delta v. या प्रकारे आपल्याला लिहिता येईल. And y. Now see this here. You can understand this. What is the value of y? Y is u minus v. Now plus u minus v and minus u minus v get cancelled. Then you will get delta u minus delta v. Now dividing on both sides by delta x. Therefore, and taking the limit as the delta x tends to 0. Therefore, limit delta x tends to 0, delta y about delta x is equals to limit delta x tends to 0, delta u minus delta v upon delta x. Now separate it. That is the limit delta x tends to 0, delta u by delta x minus limit delta x tends to 0, delta v minus upon delta x, and this is treated as a. Now we will write one thing that u and v are the functions of x. This is the common dialogue. Fourth step, u and v are differential function of x and the limit as delta x tends to 0, delta u by delta x is equals to du by dx and limit delta x tends to 0, delta v upon delta x is equals to dv by dx. This is the fourth one. The limit in the RHS exists and hence the limit on the LHS also exists. The limit delta x tends to 0, delta y upon delta x exist and is equals to dy by dx. Therefore, dy by dx is equals to du by dx minus dv by dx. Now the illustrative examples. That is, first is if y is equals to x raised to 5 by 2 minus sec x plus 1 upon x raised to 5. Now x raised to 5 by 2. To find out the derivative of this, ही power पुढे आणणार आणि त्यातनं एक मायनस करणार. That is 5 by 2 into x raised to 5 by 2 minus 1. Therefore 5 by 2 into x raised to 3 by 2 is the derivative. नंतर the derivative of sec x. The derivative of sec x is sec x into tan x. आता प्रत्येकदा डेरिव्हेटिव्ह काढताना ही जी पॉवर असते x ची ही न्यूमरेटरला असली पाहिजे. Therefore this can be written as ddx of x raised to minus 5. तो न्यूमरेटरला आणणार आपण. Now the derivative of y is equals to x raised to 5 by 2 minus sec x plus 1 upon x raised to 5. dy by dx is equals to x raised to 5 by 2 minus x raised to 3 by 2, 5 by 2 into x raised to 3 by 2 minus sec x into tan x. Now ddx of x raised to 5 and now sec x into tan x and the derivative of x, that is to find out the derivative we can write minus 5 into x raised to minus 4. By mistake this is written as 5 by 2 but here is a 3 by 2. Now the derivative of product, that is y is equals to u into v. That is there is the product of the two functions. If u and v are differentiable function of x and y is equals to u into v. यापूर्वीच्या रूल्स मध्ये आपण असं पाहिलं होतं की y is equals to u plus v, y is equals to u minus v. आता आपण काय बघणार आहोत, y is equals to u into v. When there is a product of the two functions, then dy by dx is equals to u into dv by dx plus v into du by dx. बघा तो रूल कसा आहे, dy by dx is equals to u into dv by dx plus v into du by dx. Therefore, proof is again the same dialogue. Let delta u, delta v and the delta y be the increment in u, v and y respectively corresponding to the increment delta x in x. हा प्रत्येक थेरमला हीच लाईन असणार आहे त्याच्यामध्ये. Now y is equals to u into v. Now there is a small change in y. म्हणजे y मध्ये जर थोडा बदल झाला त्याच वेळेस u आणि v मध्ये देखील बदल होणार. u कसा होणार, u plus delta u, v मध्ये v plus delta v. Now the product of these two, uv, u into delta v, v into delta u plus delta u, delta v. Now delta y is equals to u into v plus v into delta v plus u into minus y. That plus uv minus uv get cancelled. That is the delta y is equals to u into delta v plus v into delta u into delta v. Now divide on both sides by delta x. Dividing on both sides by delta x and taking the limit as a delta x tends to 0. That is the limit as a delta x tends to 0. We get limit delta x tends to 0, delta y by delta x, u into delta v plus v into delta u plus delta u into delta v upon delta x. Now we'll separate this. लिमिट डेल्टा x टेंड्स टू 0 u इंटू डेल्टा v अपॉन डेल्टा x. या डेल्टा x ने तिघांना डिवाइड करणार v इंटू डेल्टा u बाय डेल्टा x प्लस डेल्टा u इंटू डेल्टा v अपॉन डेल्टा x. आपल्याकडे एकच डेल्टा x आहे म्हणून याला डिवाइड करणार, पण याला ऍडजस्ट करताना डिवाइड बाय डेल्टा मल्टिप्लाइड बाय डेल्टा. नाउ सी दिस हियर. लिमिट डेल्टा x टेंड्स टू 0 u into delta v by delta x plus v into delta u by delta x plus delta u by delta x into delta v. Now here is a divide by delta multiplied by delta. आपल्याकडे एकच डेल्टा x होता, आपण तो डेल्टा u ला वापरला होता. Now here the u into limit of delta x tends to 0 of the delta v upon delta x plus v into limit delta x tends to 0 delta u by delta x plus limit delta x tends to 0 delta u by delta x into limit delta x tends to 0 delta v by delta x into limit delta x tends to 0 of the delta x. And now as u and v are functions of x, and therefore as delta x tends to 0, the limit exists. Differential functions of x and limit delta x tends to 0, delta u by delta x is equals to du by dx. And limit delta x tends to 0, delta v by delta x is equals to dv by dx. If the limits on the RHS exist, and therefore that is treated as a. Therefore the limit on the LHS also exists, and that is equals to dy by dx. Therefore dy by dx is equals to u into dv by dx plus v into du by dx. du by dx into dv by dx into 0. म्हणजे हे टर्म नंतरचं काय होतं, टोटल दिस बिकम 0. Therefore we get dy by dx is equals to u into dv by dx plus v into du by dx. The corollary: if u and v are and w are differentiable functions of x such that y is equals to uvw, then dy by dx is equals to. अतिशय सोपे लक्षात ठेवायला, प्रत्येकदा एकाचा डेरिव्हेटिव्ह काढायचा, दुसरे दोन्ही कॉन्स्टंट ठेवायचे. आता यामध्ये u इंटू v डेरिव्हेटिव्ह कोणाचा काढला, w चा, इंटू dw by dx प्लस u w dv by dx plus v into w du by dx. and in this way, म्हणजे हे दोन्ही कॉन्स्टंट, w चा डेरिव्हेटिव्ह, v चा डेरिव्हेटिव्ह, u चा डेरिव्हेटिव्ह. मग त्यावेळेस उरलेला जो असेल तो कीप इट इज ॲज इट इज कॉन्स्टंट. फॉर एक्झाम्पल y is equals to x raised to x cube e raised to x log of x into sin of x. मी याच्यात 4 डिफरंट टाइप्स ऑफ द फंक्शन्स घेतले आणि मग त्याचा डेरिव्हेटिव्ह काढूया. dy by dx is equals to x raised to 3 e raised to x and log of x. आता शेवटी पहिल्यांदा साइनचा डेरिव्हेटिव्ह काढलेला आहे. The derivative of sin of x is cos of x ddx of sin of x plus x cube e raised to x sin x. मग आता log of x चा डेरिव्हेटिव्ह काढला, उरलेले कॉन्स्टंट ठेवायचे, प्लस x cube log of x sin of x ddx of e raised to x. Now next is e raised to x log x sin x ddx of x raised to 3. And in this way, the first is derivative of sin of x is cos of x, derivative of log of x is 1 upon x, derivative of e raised to x is e raised to x, and derivative of x cube is 3x square. Therefore x cube e raised to x log of x, into cos of x. Next is x cube e raised to x sin x 1 upon x plus x cube log of x into sin x into e raised to x plus e raised to x log of x into sin of x 3x square derivative of x cube. Now here is the derivative of x cube. Next is a derivative of quotient म्हणजे दोन फंक्शनचा त्याच्यामध्ये कसं साइन असेल तर डिव्हिजनचं साइन असेल. That is if u and v are the differentiable functions of x and y is equals to u upon v, then dy by dx is equals to v into du by dx minus u into dv by dx where upon v square where v is not equals to 0. लक्षात ठेवायचं असेल तर कसं dy by dx is equals to v into du by dx minus u into dv by dx. खाली v square आहे मग इथेच v ने सुरुवात झालेली असेल असं लक्षात ठेवू शकता तुम्ही. परीक्षेमध्ये कन्फ्युजन नको झालं पाहिजे. u into dv by dx आहे का v into du by dx, पण आपल्याला डिनोमिनेटर माहिती असतो तर काय तो v आहे म्हणून v square म्हणजे इथे स्टार्टिंग v असेल असं. Now we'll start the proof of this rule. Again, the same dialog is there. Let delta u, delta v and the delta y be the increments in u, v and y respectively, corresponding to the increment delta x in x. प्रत्येक theorem ला हा same dialog आहे. Now y is equals to u upon v. Now if you make the product, that is v into u and v into delta u minus u into v minus u into delta v, then plus uv minus uv get cancelled. Then you will get v delta u minus u delta v upon v in bracket v plus delta v. Now dividing on both sides by delta x and taking the limit as a delta x tends to 0. Now this is very important, as a delta x tends to 0. Therefore, we get limit delta x tends to 0, delta y by delta x, limit delta x to v into delta u minus u into delta v upon v in bracket v plus delta v into delta x. Limit delta x tends to 0, v into delta u upon delta x minus u into delta v by delta x upon v in bracket v plus delta x into delta v upon delta x into delta x. Therefore, limit delta x tends to 0 v into limit delta x tends to 0 delta u by delta x minus, now see this here, minus u limit delta x tends to 0 delta v by delta x upon v plus limit delta x tends to 0 delta v upon delta x into limit delta x tends to 0 as a delta into delta x. And therefore, the limit of this becomes 0 and overall this total will become 0. Then what will remain? Only v into v, and v into v is v square. Now what about the limit of delta u upon delta x as delta x tends to 0 is du by dx. This is the dv by dx, and therefore now see this here. Now u and v are differentiable functions of x, hence the delta x tends to 0. Delta u by delta x is du by dx and limit delta x tends to 0, delta v upon delta x is equals to dv upon dx. Also, limit delta x tends to 0, of the delta x is equals to and 0, and therefore the limit on the RHS also exists of A exists, that is a limit delta x tends to 0, delta y by delta x is exists, and that is equals to dy by dx. Therefore, the rule is v into du by dx minus u into dv by dx upon v in bracket v plus delta v into 0, and that is equals to dy by dx is equals to v into du by dx minus u into dv by dx upon v square. This is you have to remember. Now, next is if y is equals to u upon v, then this is the rule. Now we start the exercise 9.2. The first is differentiate the following with respect to x. Now we start. Differentiate with respect to x. Y is equals to x raised to 4 upon 3 plus e raised to x minus sin x. Differentiate with respect to x. Therefore, dy by dx is equals to 4 upon 3 x raised to 4 upon 3 minus 1. The derivative of e raised to x is e raised to x, and the derivative of sin of x is cos of x. Therefore, this can be written as dy by dx is equals to 4 upon 3 x raised to 1 upon 3, and the derivative of e raised to x is e raised to x minus cos x. Now next, y is equals to root x plus tan x minus x raised to 3. Now the differentiate with respect to x. Y is equals to, now always remember that the derivative of root of x is 1 upon 2 times root x, and how it comes, and the derivative of tan of x is sec square x, and the derivative of x cube is 3x square. Now how the derivative of root x is 1 upon 2 root x. Now see this here, dy by dx is equals to ddx of root x. Derivative of tan of x I had written directly, and derivative of x cube is a 3x square minus 1. Therefore, root x means x raised to 1 upon 2 sec square x minus 3x square. Therefore, 1 upon 2 x raised to 1 upon 2 minus 1 plus x square x minus 3x square. 1 upon 2 x raised to minus 1 upon 2 sec square x minus 3x square, and now it is written as 1 upon 2 into 1 upon x raised to 1 upon 2 sec square x minus 3x square. That is 1 upon 2 root x plus sec square x minus 3x square. And in this way, we get the dy by dx is equals to the answer. The ddx of root of x is 1 upon 2 times root x. Now remember this always. That is 1 upon 2 root x sec square x minus 3x square. Now the next problem is y is equals to log of x minus cosec x plus 5 raised to x minus 3 upon x raised to 3 by 2. Now this is again very simple. The derivative of log of x is 1 upon x. The derivative of cosec x is minus cosec x into cot x. Derivative of 5 raised to x is 5 raised to x into log of 5. And now to find out the derivative of 3 upon x raised to 3 by 2, तर प्रत्येकदा आपल्याला हा व्हेरिएबल हा न्यूमरेटरला आणायचा असतो. Therefore x raised to minus 3 by 2. Now see this. Therefore dy by dx differentiate with respect to x असं प्रत्येकदा आपण लिहिणार. dy by dx is equals to 1 upon x, derivative of log of x is 1 upon x, and the derivative of cosec x is minus cosec x into cot x. 5 raised to x, the derivative 5 raised to x log of 5 minus ddx of minus 3 by 2 minus 3 by 2 minus 1 minus 3 by 2 आपण पुढे घेतला त्याच्यातनं एक मायनस करणार. x raised to minus 3 by 2 minus 1 means what? x raised to minus 5 by 2. Now see this here, 1 upon x, minus minus will become this plus 5 raised to x log of 5. Again this minus minus will become plus x raised to minus 5 by 2. 1 upon x plus cosec x into cot x, x raised to 5 log of 5 9 by, and therefore this is the dy by dx. Now if you want to see this, this is the dy by dx. Therefore the dy by dx is equals to 1 upon x plus cosec x into cot x 5 raised to x log of 5 plus 9 upon 2 into x raised to 5 by 2. Now next problem, number 4. Y is equals to x raised to 7 upon 3 plus 5 x raised to 4 upon 3 minus 5 upon x raised to 2 upon 3. Now we'll find out the derivative. हा देखील आपण न्यूमरेटर आणलाय. प्रत्येकदा तो फंक्शन हा न्यूमरेटरलाच असला पाहिजे. 5 into x raised to minus 2 upon 5 डिफरन्शिएट विथ रिस्पेक्ट टू x. त्याच्या पॉवर मधनं 1 करणार आणि ती आधीची पॉवर पुढे लिहिणार. दॅट इज 7 upon 3 x raised to 7 upon 3 minus 1. 5 into 4 upon 5 x raised to 4 upon 5 minus 1 minus 5 into minus 2 by 3 into x raised to minus 2 by 3 minus 1. Therefore 7 upon 3 x raised to 4 upon 3 plus 4 x raised to minus 1 upon 5. And now this minus minus will become plus 2 get 5 get cancelled plus 2 into x raised to, the derivative is 4 into x raised to minus 1 upon 5, 2 into x raised to minus 7 upon 5, and therefore 7 upon 3 x raised to 4 upon 3. The power upon plus करणार, that is a 4 upon x raised to 1 upon 5 plus 2 upon x raised to 7 upon 5, and this is the dy by dx. Now fifth, y is equals to 7 raised to x plus x raised to 7 minus 2 upon 3 x root x minus log of x plus 7 raised to 7. Now here is a x into root x means what? X raised to 3 by 2 minus log of x 7 raised to 7. Differentiate with respect to x. Therefore dy by dx is equals to 7 raised to x log of 7 plus x raised to 7 means what? 7 into x raised to 6 minus 2 upon 3, 3 upon 2, x raised to 3 by 2 minus 1, and the derivative of log of x is 1 upon x, and derivative of constant is 0. Therefore this is the 0. Now normal simplification is 7 raised to x log of 7 plus 7x raised to 6 minus x raised to 1 upon 2 minus 1 upon x plus 0. 2 upon 3 into 3 upon 2 get, therefore dy by dx is equals to 7 raised to x log of 7 plus 7x raised to 6 root x, x raised to 1 upon 2 means what? Root x minus 1 upon x. Now the 6, y is equals to 3 cot x minus 5 e raised to x plus 3 log of x minus 4 upon x raised to 3 by 2. Now again y is equals to 3 cot x minus 5 e raised to x plus 3 log x minus 4 into x raised to minus 3 by 4. Now differentiate with respect to x. dy by dx is equals to derivative of cot of x minus 5 derivative of e raised to x plus 3 derivative of log of x minus 4 ddx of x raised to minus 3 by 4. Now the derivative of cot of x is minus cos x square x, derivative of e raised to x is e raised to x, and that's why minus 5 e raised to x plus 3 into derivative of log of x is 1 upon x, that is a 3 upon x minus, now see this here, the derivative of x raised to minus 3 by 4, now this is minus 4 into minus 3 by 4 into x raised to minus 3 by 4 minus 1. Therefore, minus 3 cos x square x minus 5 into e raised to x 3 upon x minus will become plus 3x raised to minus 7 upon 4 minus 3 cos x square x minus 5 e raised to x 3 upon x 3 into x raised to 7 upon 4. Now question number 2. Differentiate with respect to x the following. That y is equals to x raised to 5 into tan of x. Now here is a product of the two functions. That is, dy by dx is equals to u into dv by dx plus v into du by dx. Differentiate with respect to x. I am writing the rule. Therefore, dy by dx is equals to, that is x raised to 5 derivative of tan of x plus tan of x into derivative of x raised to 5. The derivative of tan of x is a sec square x plus tan of x into derivative of x raised to 5 is 5x raised to 4. That is a dy by dx is equals to x raised to 4 common. Now you can see this. The final answer is dy by dx is equals to x raised to 4 in bracket x sec square x plus 5 tan x. Now next, y is equals to x cube into log x, y is equals to u into v, dy by dx is equals to x cube into log of x, that is x cube into ddx of log x plus log of x into ddx of x raised to 3. Now the derivative of log of x is 1 upon x. Log of x into derivative of x raised to 3, that is a 3x square. Therefore, x, y, z cancel, you will get x square plus 3x square into log of x. Therefore, dy by dx is equals to x square plus 3x square into log of x. Now, from these two, we can take x square as a common. Then in bracket, you will get x square in bracket 1 plus 3 into log of x. This is the dy by dx. Now third, y is equals to x square plus 2 bracket square into sin x. Therefore, dy by dx is equals to, we can expand this, x raised to 4 plus 2x square plus 4. That is a plus b bracket square into sin of x by using that formula. Therefore, differentiate with respect to x and dy by dx is equals to x raised to 4, 4x square plus 4. Keep as it is. First, find out the derivative of sin of x, and derivative of sin of x is cos x plus sin x as it is ddx of x raised to 4, 4x square plus 4. That's a derivative partner. X raised to 4, 4x square plus 4. Derivative of sin of x is a cos x plus sin x as it is, and the derivative of x raised to 4 is 4x cube. Derivative of 4x square 8x, and the derivative of 4, which is the constant, and the derivative of constant is 0. Therefore, Now see this here. X square plus 2 bracket square into cos of x, 4x common, x square plus 2 into sin x. X square plus 2 brackets, take x square plus 2 common, then in bracket you will get x square plus 2 into cos x plus 4x into sin x. Now fourth one, y is equals to a raised to x into log of x. Differentiate with respect to x. dy by dx is equals to a raised to x ddx of log x plus log of x into ddx of e raised to x. Derivative of log of x is 1 upon x. Log of x into derivative of e raised to x is e raised to x. E raised to x, derivative of log of x is 1 upon x plus log of x and derivative of e raised to x is e raised to x. Take e raised to x common, then in bracket you will get 1 upon x plus log of x. dy by dx is equals to e raised to x in bracket 1 upon x plus log x. Y is equals to 5u. Y is equals to e. X raised to 3 by 2. E raised to x log of x. Now this is a u, v, w. Therefore the rule is u into derivative of w, uw derivative of v plus vw derivative of u. Therefore x raised to 3 by 2 into e raised to x into log of x, differentiate with respect to x. X raised to 3 by 2 e raised to x, and now find out the ddx of log of x. The derivative of log of x is 1 upon x. X raised to 3 by 2 into log of x into ddx of e raised to x. The derivative of e raised to x is e raised to x. Log of x, e raised to x into ddx of x raised to 3 by 2. The derivative of x raised to 3 by 2 is a 3 by 2 into x raised to 1 upon 2. Now see this here. Derivative of log of x is 1 upon x. Therefore x raised to 3 by 2 into e raised to x into 1 upon x plus x raised to 3 by 2 log of x. Derivative of e raised to x is e raised to x. Now see this again. The simplification is also important. Now ddx of x raised to 3 by 2. That is a 3 by 2. And या 3 by 2 मधनं 1 minus केला. Then you will get x raised to 1 upon 2. Now here is x raised to 3 by 2 upon x. मग यामध्ये काय होणार की 3 by 2 means what? X into root x. X will get cancelled and then you will get root x. Now see this here. E raised to x. Take the common. इथे root x कसा आला बघा. X raised to 3 by 2 upon x. X raised to 3 by 2 means what? 1x. And x into root x. Therefore root x is remaining here. X raised to 3 by 2 log of x. या टर्मच्या बाबतीत दोघातनं या तिघातनं e raised to x कॉमन गेला. X raised to 3 by 2 into log x plus 3 by 2 log of x root x. And therefore again we are taking the root x is here. X raised to 3 by 2 यातनं देखील आपल्याला एक root x मिळेल आणि x शिल्लक राहणार तिथे आणि हा एक root x. Therefore we are also taking root x into e raised to x plus in bracket 1 plus x into log of x plus 3 by 2 log of x. Therefore divided by dx. Now the next is 6. Y is equals to log of e raised to x cube dot log of x cube log of e raised to x cube dot e raised log of x cube. इथे कसं केलं आपण the rules of the logarithmic, that is the log of m raised to n. मग n आपण पुढे घेतो. तसंच इथे किती घेतलाय x cube हा पुढे घेतलाय x cube log of e, and here is base is also e. Therefore log of e to the base e is 1. यासाठी काय घेतलंय log of x cube. मग इथे आपण हा 3 पुढे घेणार बघा 3 log of x by using this log rule. m times log of a. हा इथे m पुढे घेऊ शकतो आपण. Now next simplification. X cube 3 log of x. Log of e to the base e is 1. Now again simplification. 3x cube into log of x. Now differentiate with respect to x now. The derivative of 3x cube divided by x is equals to 3x cube. Derivative of log of x is 1 upon x. Log of x as it is ddx of 3x cube. Log of x चा derivative किती? तर 1 upon x. That is a 3x cube upon into 1 upon x. Log of x into 3 into 3x square. Now here is x cube upon x. X get cancelled. You will get 3x square. That is a 9x square. This is the 9x square log of into log of x. Divided by x is equals to 3x square. आपण हे कॉमन काढू शकतो. Then in bracket you will get 1 plus 3 log of x. Now next is third. Differentiate with respect to x. Y is equals to x square root x plus x raised to 4 into log of x. मग यामध्ये देताना इथे प्रॉडक्ट रूल अप्लाय करणार, मध्ये प्लस साइन ठेवणार, या दोघांमध्ये प्रॉडक्ट रूल आपण अप्लाय करणार. नाउ x raised to root x means what? X raised to 1 upon 2. Therefore we will differentiate this. That is x raised to 5 by 2. इथे प्रॉडक्ट रूल नाही, तर पॉवर आपण ऍड करणार ती. See this y is equals to x raised to 3 by 2 plus x raised to 4 into log of x. X raised to 5 by 2. X raised to 5 by 2 चा डेरिव्हेटिव्ह किती येणार? 5 by 2 into x raised to 5 by 2 minus 1. 5 by 2 minus 1 म्हणजे किती? तर 3 by 2. Now see this here. ddx of x raised to 5 by 2 and now ddx of x raised to 4 into log of x. X raised to 5 by 2. 5 by 2 minus 1 means what? 3 by 2. आता इथे प्रॉडक्ट रूल अप्लाय करून आपण काय शोधणार त्याचा? तर डेरिव्हेटिव्ह शोधणार. x raised to 4 ddx of log of x plus log of x into derivative of x raised to 4. 5 by 2 x raised to 3 by 2 plus x raised to 4 derivative of log of x is 1 upon x. Log of x raised to 4 चा डेरिव्हेटिव्ह किती? 4x cube. Therefore 5 by 2 x raised to 3 by 2. आता इथे x raised to 4 into 1 upon x. Now x will get cancelled. You will get x cube. आणि पुढे 4x cube into log of x. And let's say the answer divided by dx is equals to 5 by 2 x raised to 3 by 2 plus x cube plus 4x cube and 2 log of x. Now या दोघातनं मग काय x cube कॉमन काढलाय? नाही काढला तरी चालेल. If you want to see, you can x cube कॉमन काढलेला आहे. या स्टेप मध्ये नाही कॉमन काढला, एवढं जरी आन्सर लिहिलं तरी चालू शकेल. Second, y is equals to e raised to x into sec x minus x raised to 5 by 3 into log of x. Now differentiate with respect to x. E raised to x into sec x याला product rule apply करणार आणि x raised to 5 by 2 into log of x याला देखील product rule apply करणार. Now see this here, e raised to x. This is important. या दोघांना product rule apply करणार. Now what is the derivative of e raised to x? Derivative of e raised to x is e raised to x. Sec x चा डेरिव्हेटिव्ह किती येणार? sec x into tan x and log of x चा 1 upon x and x raised to 5 by 2 म्हणजे काय? 5 by 3 सॉरी 5 by 3 पुढे घेणार 5 by 3 minus 1. Now see this here. That is the ddx of e raised to x into sec x minus ddx of x raised to 5 by 3 into log x. E raised to x as it is, derivative of sec x plus sec x into ddx of e raised to x. And next is यानंतर x raised to 5 by 3 into log of x plus log of x into ddx of x raised to 5 by 3. E raised to x, derivative of sec x is sec x tan x plus sec x into e raised to x minus x raised to 5 by 3 log of x derivative 1 upon x plus log of x into derivative of x raised to 5 by 3 means what? 5 by 3 into x raised to 5 by 3 minus 1 means it is a 2 by 3. See this here? That is a e raised to x into sec x tan x plus sec x into e raised to x हा एवढा पार्ट झाला मायनस या स्क्वेअर ब्रॅकेट मध्ये x raised to 5 by 3 into 1 upon x म्हणजे 1 या 5 by 3 मधनं मायनस करणार याची पॉवर that is a 5 by 3 minus 1 means what? x raised to 3 by 2 हा इथे आलेला आहे. नंतर log of x as it is इथे आहे and 5 by 3 x raised to 2 by 3. Now see this again. That is from these two we will take as a e raised to x and sec x common. E raised to x into sec x in bracket tan of x plus 1 minus x raised to 3 by 2 in bracket you will get 1 plus 5 by 2 5 by 3 log of x. Divided by x equals to third y is equals to x raised to 4 x root x cos x minus x square e raised to x. Therefore divided by now see this again x root x means x ची power इथे किती 1 आहे आणि इथे किती हाफ आहे 1 plus half that is a 3 by 2 cos x plus इथे x raised to 4 चा डेरिव्हेटिव्ह 4x cube x raised to 3 by 2 चा डेरिव्हेटिव्ह किती येणार that is a 3 by 2 into root x. त्याला प्रॉडक्ट रूल अप्लाय करणार आपण मात्र याचा देखील प्रॉडक्ट रूल अप्लाय करणार x स्क्वेअर चा डेरिव्हेटिव्ह 2x येणार आणि e raised to x चा डेरिव्हेटिव्ह e raised to x येणार. नाउ सी दिस by applying the proper rules. Differentiate with respect to x. ddx of x raised to 4 plus x raised to 3 by 2 cos x minus x square e raised to x. ddx of x raised to 4 plus ddx of x raised to 3 by 2 into cos x minus ddx of x square dot e raised to x. X raised to 4 चा डेरिव्हेटिव्ह 4x cube x raised to 3 by 2 into cos x याला product rule apply करणार x raised to 3 by 2 into derivative of cos x. The derivative of cos x is minus sin x and the cos x into ddx of x raised to 3 by 2 minus x square into e raised to x square ddx of e raised to x is e raised to x. Next is plus e raised to x into derivative of x square is a 2x that is equals to 4x cube x raised to 3 by 2 derivative of cos x is minus sin x cos x derivative of x raised to 3 by 2 is a 3 by 2 into x raised to 1 upon 2 and next is x square derivative of e raised to x is e raised to x जसा तसा x square चा derivative 2x ब्रॅकेट ओपन केला म्हणजे इथे मायनस साइन मिळालं इथे मायनस साइन मिळणार. Now the normal simplification. X raised 4x cube minus x raised to 3 by 2 into sin x plus 3 root x upon 2 cos x x square e raised to x minus 2x e raised to x that is a 4x cube minus x raised to 3 by 2 sin x plus 3 by 2 root x cos x आणि या दोघांतून देखील आपल्याला काहीतरी कॉमन काढता येते that is x into e raised to x in bracket x plus 2 bracket complete and this is the final answer. Now the fourth one y is equals to x raised to 3 minus 2 tan of x minus x cos x 7 raised to x into x raised to 7. Now differentiate with respect to x. Now इथे अपन product rule apply करणार इथे product rule इथे देखील product rule. The example is simple. ddx of x that is x cube minus 2 tan x minus ddx of x cos x plus ddx of x 7 raised to x into x raised to 7. X cube minus 2 as it is, derivative of tan x plus tan x as it is, ddx of x cube minus 2. नंतर x cos x साठी देखील product rule apply करणार minus x as it is, ddx of cos x is minus sin x. Cos x as it is, the derivative of x is 1. And ddx of 7 raised to x into x raised to 7 is 7 raised to x. ddx of x raised to 7 is 7x raised to 6. Now normal simplification is here. You can see. Therefore, dy by dx x cube minus 2 sec square x plus 3x square tan x वरचा जसं तसं घेतलेलं. Now next is a plus x sin x minus sign ऑपरेट करणार आपण तिथे. This minus minus will become plus x sin x आणि हा plus आणि हा minus. Overall it will become minus cos x plus 7 raised to x raised to 6. If we take the 7 raised to x and x raised to 6 common, you can see this again. Okay, now see this next example. That is y is equals to sin x into log x plus e raised to x cos x minus e raised to x into root x. Differentiate with respect to x. ddx of sin x into log x plus e raised to x cos x minus e raised to x root x. Now we'll apply here the product rule. या दोघांसाठी product rule apply करणार. या दोघांना product rule, या दोघांना product rule. Okay. Sin x ddx of log x plus cos x log of x ddx of sin x याच्यासाठी देखील तसंच करणार. Now see this again. Separate करणार आपण ते आधी. ddx of product rule sin x as it is, derivative of log of x is 1 upon x. Now next is e raised to x into cos x plus cos x into derivative of e raised to x. E raised to x derivative of root of x plus root x into derivative of e raised to x. That is a sin x derivative of log of x is 1 upon x plus log of x derivative of sin of x is a cos x plus the log x derivative of sin x e raised to x derivative of cos x is minus sin x आणि यासाठी देखील product rule apply करणार. That is a e raised to x derivative of root x is 1 upon 2 root x plus root x into derivative of e raised to x is e raised to x. Now normal simplification is here. That is sin x upon x पहिलं टर्म आलं. दुसरं काय येणार cos of x into log of x. पुढे काय येणार minus e raised to x into sin x. E raised to x into sin x. E raised to x into cos x minus e raised to x upon 2 root x minus root x into e raised to x sin x upon x cos of x into log of x minus that is a e raised to x as a common. Then in bracket we can write minus sin x plus cos x minus 1 upon 2 root x minus root x, and in this way we can have the answer dy by dx is equals to sin x upon x plus log of x into cos x plus e raised to x in bracket minus sin x plus cos x minus 1 upon, now this is the simplification. If you take the minus n common, then in bracket you will get root x plus 1 upon 2 root x. That is dy by dx is equals to sin x upon x plus cos of x into cos x e raised to x minus sin x plus cos x minus, now this is simplification, root x into 2 root x, that is a 2 root x into root x is x, that is a 2x plus 1 upon 2 root x. Now the 6 y is equals to e raised to x into tan of x plus cos of x log of x minus root of x y raised to x. Differentiate with respect to x, ddx of e raised to x tan x plus cos of x into log of x minus root x phi raised to x. ddx of e raised to x tan x plus ddx of cos of x into log of x minus ddx of root of x into phi raised to x. Now simple here, we'll apply the product rule. E raised to x into derivative of tan of x plus tan of x as it is, derivative of e raised to x plus cos of x into derivative of log of x plus log of x into derivative of cos of x minus in square bracket x phi raised to x derivative of root x into derivative of phi raised to x, and in this way, that is a, you will get e raised to x tan the derivative x for x, tan x derivative of e raised to x is e raised to x, cos x derivative of log of x is 1 upon x, minus sin x derivative of cos of x is minus sin x into log of x minus phi raised to x derivative of root of x is 1 upon 2 root x as it is, and derivative of phi raised to x is phi raised to x into log of 5. Therefore e raised to x into sec square x plus tan x into e raised to x cos x upon x minus sin x log of x minus, that is phi raised to x common, then you will get 1 upon 2 root x plus root x into log of 5 e raised to x sec square x plus, if we are taking the e raised to x common from these two, cos of x upon x minus sin log of x into sin x phi raised to x in bracket, that is a 2 root x into root x log of x. Root x will become x. Therefore 2x log of 5 plus 1 upon 2 root x. This is the normal simplification. You can have this answer again. See this here. This is the answer. Final answer. Divided by dx. Now next is fourth one. Differentiate the following with respect to x. Now here we will apply the important rule, quotient rule, x square plus 3 upon x square minus 5, y is equals to e upon v. Therefore, dy by dx is equals to v into du by dx minus u into du by dx upon v square. Now y is equals to x square plus 3, x square minus 5. Now differentiate with respect to x. Dy by dx is equals to x square minus 5 into ddx of x square plus 3 minus x square plus 3 into ddx of x square minus 5 upon x square minus 5 bracket square. Now the derivative of x square is 2x. Derivative of x square is again 2x. Derivative of 3 is 0 because it is a constant. And derivative of 5 is also 0. Now normal simplification is here. X square minus 5 into 2x minus x square plus 3 into 2x upon x square minus 5 bracket square. Now see this here. 2x common, then in bracket you will get x square minus 5 minus in bracket x square plus 3 x square minus 5 bracket square. Again see this after simplification. That is a 2x square minus 5 minus x square minus 3. Now plus x square minus x square get cancelled. Therefore 2x you will get 2x minus 8 upon x square minus 5 bracket square. Therefore dy by dx is equals to minus 16x upon x square minus 5 bracket square. Now the next is y is equals to root x plus 5 upon root x minus 5. Now differentiate this with respect to again x. Quotient rule. That is a root x minus 5 into ddx of root x plus 5 minus root x plus 5 into ddx of root x minus 5 upon root x minus 5 bracket square. Now what is the derivative of root x? 1 upon 2 root x, and derivative of 5 is 0, which is a constant. Minus root x plus 5, derivative of root x is 1 upon 2 root x, and derivative of again 5 is 0. That is, now the normal simplification is here again. Root x minus 5 bracket square. That is it. Now we'll take 1 upon 2 root x minus 5 minus root x plus 5, root x minus 5 bracket square, root x minus 5. Now if we open the bracket, root x minus 5 minus root x minus 5 plus root x minus root x get cancelled. That is a 2 root x in bracket root x minus 5 bracket square plus root x minus root x get cancelled, minus 5 minus 10. That is a 2 root x in bracket root x minus 5 bracket square. This is the dy by dx. That is a minus 5 upon root x into root x minus 5 bracket square. Now the problem number 3, y is equals to x root x, y is equals to x into e raised to x upon x plus e raised to x. Now differentiate with respect to x, apply the quotient rule. This is the now series rule. After that I will show you. That is it. Dy by dx is equals to, this is the v x plus e raised to x into ddx of x root x. आता x root x चा डेरिव्हेटिव्ह काढताना आपल्याला इथे प्रॉडक्ट रूल अप्लाय करावा लागणार आहे. मायनस x into e raised to x ddx of x plus e raised to x upon x plus e raised to x bracket square. Therefore x plus e raised to x. Now here we will apply the product rule. X as it is, derivative of e raised to x is e raised to x plus e raised to x and derivative of x is x minus x e raised to x. Derivative of x is 1, derivative of e raised to x is e raised to x. X plus e raised to x bracket square. X plus e raised to x, e raised to x are derivative of e raised to x. Therefore x into e raised to x. Derivative of x is 1. 1 into e raised to x is e raised to x only here. Therefore it is written as e raised to x minus x into e raised to x. Derivative of x is again 1 here. and e raised to x. Derivative of e raised to x is e raised to x of sin theta upon. Now I'm repeating again this, that is y is equals to x into e raised to x upon x plus e raised to x. Differentiate with respect to x. Dy by dx is equals to, this is the first, that is a x plus e raised to x into ddx of x into e raised to x minus x into e raised to x into ddx of x plus e raised to x upon x plus e raised to x bracket square x plus e raised to x into ddx of x into e raised to x. Now we will apply here the product rule. Keep the x as it is and derivative of e raised to x is e raised to x. Now next is plus e raised to x into ddx of x minus x into e raised to x ddx of x e raised to x. Derivative of x is 1 and derivative of e raised to x is e raised to x upon x plus e raised to x bracket square. X plus e raised to x, that is x into e raised to x plus e raised to x. Derivative of x is 1 minus x into e raised to x 1 plus e raised to x upon x plus e raised to x bracket square. Now the normal simplification is there. X plus e raised to x into e raised to x in bracket x plus 1 minus x into e raised to x into 1 plus e raised to x upon x plus e raised to x bracket square. Therefore, now simplification, we can take e raised to x common from the numerator and then in bracket you will get x into e raised to x into x plus 1 minus x into 1 plus e raised to x bracket complete x plus e raised to x bracket square. Now the normal simplification, e raised to x in bracket x square plus x into e raised to x plus e raised to x minus x into e raised to x bracket complete upon x plus e raised to x bracket square. Now the normal simplification is here, plus x and minus x get cancelled. X into e raised to x minus x into e raised to x, these two terms get cancelled. Therefore, e raised to x into x square plus e raised to x upon x plus e raised to x bracket square. Dy by dx is equals to e raised to x in bracket x square plus e raised to x upon x plus e raised to x bracket square. Now the fourth example. Y is equals to x into log of x upon x plus log of x. Now differentiate this with respect to x. That is a dy by dx is equals to x plus log of x into ddx of x log of x. आता इथे x into log of x आहे म्हणजे आपल्याला इथे प्रॉडक्ट रूल अप्लाय करावं लागणार पहिल्या टर्म साठी. x into log of x minus x log of x and ddx of x plus log x upon x plus log x bracket square. Now we will simplify here x plus log x. Now the product rule, by using the product rule we will find out the derivative of x into log x. First upon keep x as it is, derivative of log of x is 1 upon x plus log of x into derivative of x minus x log of x ddx of x plus log of x. Derivative of x is 1 and the log of x is a 1 upon x. Divided by x plus log x bracket square. X plus log x, log of x the derivative 1 upon x, that x into 1 upon x, that get cancelled, you will get 1. Now the next is 1 into log of x, derivative of x is 1. Here is the derivative of x is 1, that is the 1 into log x. Here is the 1 into log x. Next step, minus x log of x into in bracket 1 plus 1 upon x, x plus log x bracket square. Now normal simplification is there. that is x into 1 upon x, that is you will get 1 into log x, that is a log x, minus x log x, and after simplification 1 plus 1 upon x, that simplification is x plus 1 upon x, whole divided x plus log x bracket square. Now x plus log x in bracket 1 plus log x minus x in bracket x plus 1 into log x upon x plus log x bracket square. Now again simplification, x plus x into log x plus log x plus log x bracket square minus x log x minus log of x upon x plus log x bracket square. Now the terms get cancelled. X log x minus x log x, log of x and minus log of x, this get cancelled, and you will get, that is the therefore dy by dx is equals to x plus in bracket log of x bracket square upon x plus log of x bracket square. Now the fifth problem, y is equals to x square sin x upon x plus cos x. Now differentiate with respect to x, dy by dx is equals to ddx of x square into sin x upon x plus cos x. And write this also. Now the next step is x plus log x. We'll apply the quotient rule, that is v into du by dx, that is a x cos x into ddx of v u, that is x square sin x minus u into ddx of v, that is x plus cos x upon v square, that is x plus cos x bracket square. And that's why x plus cos x, derivative of x square into sin x. Now here we will apply the product rule. Derivative of x square is a 2x and derivative of sin of x is a cos of x. But first of all, here we will apply the product rule, that is x square into ddx of sin x plus sin x into ddx of x square minus x square into sin x in bracket ddx of x plus ddx of cos of x upon x plus cos of x bracket square. Now again x plus cos of x in bracket x square, derivative of sin of x is cos of x, sin x into derivative of x square is a 2x minus x square sin x in bracket 1 plus minus sin x bracket complete upon x plus cos of x bracket square. Now x plus cos x in bracket is multiplication x cube into cos x. This x is multiplied with the x square cos x, then you will get x cube cos of x. Then x into 2x sin x means you will get 2x square sin x minus next is a cos of x into x square cos x, then you will get x square cos square x, cos of x into 2x sin x, that is a 2x sin x into cos x minus x square sin x plus x square sin square x upon x plus cos x bracket square. X cube cos x plus 2x square cos x plus x square. Now here is important, that is a x square cos x cos square x square sin square x. Now we'll take x square as a common, then in bracket you will get sin square x plus cos square x plus, now here is a 2x sin x into cos x, that is a 2 sin x into cos x means what, sin of 2x, and this is the x, therefore x into sin of 2x minus, that is a sin square x plus sin square x Next step is x cube cos x plus x square sin square x. Now here is a sin square x plus cos square x, that is a 1, plus x into sin of 2x upon x plus cos x bracket square. X square in bracket x cos x plus sin x plus 1 plus x sin of 2x x plus cos of x bracket square. Therefore dy by dx is equals to x square into x cos x plus sin x plus 1 plus x into sin of 2x upon x plus cos of x bracket square. Now again we can see this. This is the final. Now next, dy by dx is equals to x square in bracket x cos x plus sin x plus 1 plus x sin of 2x upon x plus cos of x bracket square. Now next is question number 6, problem number 6. Y is equals to 5 e raised to x minus 4 upon 3 e raised to x minus 2 differentiate with respect to x. Again the quotient rule. Now see this here. That is here is a v 3 e raised to x minus 2 into ddx of 5 e raised to x minus 4 minus 5 e raised to x minus 4 into ddx of 3 e raised to x minus 2 upon v square means what? 3 e raised to x minus 2 bracket square. Now we will find the derivative of 5 e raised to x. The derivative of 5 e raised to x. That the derivative of e raised to x is written e raised to x. Derivative of 4 is 0 here. Minus 5 e raised to x minus 4. Again the derivative of 3 e raised to x. Derivative of e raised to x is e raised to x into 3. And the derivative of 2 is 0 upon 3 e raised to x minus 2 bracket square. 3 e raised to x minus 2, 5 e raised to x, and 5 e raised to x minus 4 into 3 e raised to x upon 3 e raised to x minus 2 bracket square. Therefore, again normal simplification. We can take e raised to x common. 5 in bracket 3 e raised to x minus 2 minus 3 in bracket 5 e raised to x minus 4 upon 3 e raised to x minus 2 bracket square. And this is the d, that is e raised to x in bracket. Now normal multiplication, 5 into 3 raised to x is a 15 e raised to x minus 10 minus 15 e raised to x plus 12 upon e raised to 3x minus 2 bracket square. Now plus 15 e raised to x minus 15 e raised to x get cancelled. You will get minus 10 plus 2. That is a 2 e raised to x in bracket 3 e raised to x minus 2 bracket square. Therefore the dy by dx is equals to, you can also see here, okay. Now the next is fifth one. If f of x is a quadratic polynomial such that f of 0 is equals to 3, f dash of 2 is 2, and f dash of 3 is 12, then find f of x. Now here is f of x is equals to x square plus bx plus c. This is the quadratic polynomial, and we have given the values. F of 0 is 3. Means what? F of 0, x is replaced by 0. This you will get 0, 0, and c. And c is equals to 3. The value of c is 3. Therefore, f of 0 is equals to, x is replaced by 0, that is equals to 3. C is equals to 3. Now the next is f of x is equals to x square plus bx plus c. F dash of x is equals to 2ax plus b. F dash of 2 means x is replaced by 2. That is, a 2 is equals to 2a into 2 plus b. Therefore, 4a plus b is equals to 2. This is equation number 1. F dash of 3, that is a 2a into 3 plus b, that is equals to 12. That is 6a plus b is equals to 12. This is equation number 2. Now solve these two equations. Equation 2 minus 1, 6a plus b is equals to 12. 4a plus b is equals to 2. Subtraction. b get cancelled. 2a is equals to 10, a is equals to 5. Put a is equals to 5, then you will get b. That is a 20 plus b is equals to 2. b is equals to 2 minus, that is a minus 18. b is equals to minus 18. Therefore, we have all the three values. That is f of x is equals to x square plus bx plus c. A is equals to 5, b is equals to minus 18, c is equals to 3. Now substitute the values of a, b, c here. You will get 5x square minus 18x plus 3. This is the polynomial. Now next question. If f of x is equals to a sin x minus b cos x, f dash of x is equals to a cos x minus, now what is here? That we find the derivative of this function. A is a constant, derivative of sin of x is cos of x, and derivative of cos of x is the minus sin x. Now this minus minus will become plus. Therefore, f dash of a cos x plus b sin x, f dash of pi by 4. That is the value we have given, f dash of pi by 4 is root 2. And now here x is replaced by pi by 4 plus b sin of pi by 4. Root 2 is equals to a into 1 upon root 2 plus b into 1 upon root 2. That is, you will get root 2 is equals to, take 1 upon root 2 as common, in bracket a plus b. Therefore, now here what is here? This 1 upon root 2 will be multiplied by to the root 2. That is, you will get a plus b is equals to root 2 into root 2, which is equals to 2. A plus b is equals to 2. This is the equation number 1. Next, f dash of x is equals to a cos x plus b sin x. F dash of pi by 6 is equals to 2 a cos of pi by 6 plus b sin of pi by 6. Now the value of cos of pi by 6 is root 3 upon 2 and sin of pi by 6, that is sin 30, is 1 upon 2. This is the cos of 30 is root 3 upon 2. Now the simplification, that is a 2 is equals to 1 upon 2. We have taken 1 upon 2 as a common. Then this 2 into 2, that is a 4. Therefore, you will get root 3a plus b is equals to 4. Therefore, root 3a plus b is equals to 4. This is equation number 2. Equation 2 minus 1. Their subtraction, root 3a plus b is equals to 4. A plus b is equals to 2. Now make their subtraction. b get cancelled. You will get root 3 if we take root 3 minus a, take a common, root 3 minus 1 into a is equals to 2. Therefore, a is equals to 2 upon root 3 minus 1. Now we rationalize the denominator, that is multiplied to the denominator by root 3 plus 1, root 3 minus 1 into root 3 plus 1. Therefore, you will get 2 in bracket root 3 plus 1 upon 3 minus 1. That is, a is equals to 2 in bracket root 3 plus 1 upon 2. This 2 get cancelled, and overall you will get root 3 plus 1. Therefore, a plus b is equals to 2. And the value of b, we have substituted the value of a, root 3 plus 1 plus b is equals to 2. Therefore, b is equals to 2 minus a purna term upon राईट हँड साईडला आणणार, त्यामुळे त्याला ब्रॅकेट करणार आणि तो ब्रॅकेट ओपन करणार. therefore 2 minus root 3 minus 1, therefore you will get 2 minus 1, which is 1 minus root 3. This is the value of b. F of x is equals to a sin x minus b cos x. The value of a is root 3 plus 1 into sin x minus 1 minus root 3 into cos x. This is the f of x. I'll change. That is the minus sign is operated here. That is the 1 will become minus and root 3 will become plus. Therefore, here we have written root 3 minus 1 into cos of x. And root 3 plus 1 into sin x is as it is. Therefore, the next is problem number 4. Fill in the blanks. That is, this is the activity. Now, this is very simple. That y is equals to e raised to x into tan x. This is simple activity. Dy by dx is equals to, we apply here the product rule. Dx of e raised to x into tan x. Now, e raised to x as it is. E raised to x into derivative of tan x plus tan of x into derivative of e raised to x. The derivative of tan of x is as x square x and derivative of e raised to x is e raised to x. Therefore, here we will see here e raised to x into x square x plus tan of x into e raised to x. Now take e raised to x as a common. Therefore, in bracket you will get x square x plus tan x, bracket complete. Now what we want to write in the square bracket, that I had done here. Again, see this here. Okay. Next activity. Dy by dx is equals to sin of x upon x square plus 2. Now here we will apply the quotient rule. That is a differentiate with respect to x. Dy by dx is equals to x square plus 2 into ddx of sin x minus sin x into ddx of x square plus 2 upon x square plus 2 bracket square. Now derivative of sin of x is cos of x minus sin x into derivative of x square plus 2 is a 2x plus 0 upon x square plus 2 bracket square. Now the normal simplification is here. That is in bracket x square plus 2 into cos x minus 2x into sin x upon x square plus 2 bracket square. Therefore, now here we will do the squares. That is, next is okay, you can write down this. The next activity, that y is equals to 3x square plus 5 into cos of x. Differentiate with respect to x. Dy by dx is equals to ddx of in bracket 3x square plus 5 into cos x. Therefore, 3x square plus 5 into derivative of cos of x plus cos of x into derivative of 3x plus 3x square plus 5. And therefore, derivative of cos of x is minus sin x. Cos of x is minus sin x plus cos of x into, that is 6x, 3x square plus 5. That is the derivative of 3x square is 6x and the derivative of 5 is 0. Therefore, we can write now. Normal simplification is 3x square plus 5 minus sin x plus cos of x in 6x into cos of x. Now, here is a cos x, 3x square plus 5 cos x. Now the fourth one. Now differentiate this with that is a tan of x and the sec of x with respect to x using the formula of the differentiation. Then what do you mean by that is a u upon v and 1 upon v respectively. Now here we will apply the differentiation of that is a u upon v only. That is a, in this case and not 1 upon v. That is a differentiation of the 1 upon v, the minus 1 upon v square into derivative of v, because we have to learn, we have not learned the composite function, differentiation of the composite function. Now this is the very, that is we will apply here actually u upon v and not 1 upon v. In the textbook it is given 1 upon v, but I say that overall it is a u upon v only. But because the derivative of 1 upon v is a minus 1 upon v square into derivative of v. Let us solve this. Y is equals to tan x is equals to sin of x upon cos of x. Y is equals to u upon v. We will apply the quotient rule, that is a v into du by dx minus u into dv by dx upon v square. That is a cos x into derivative of sin x minus sin x into derivative of cos x upon v square, means what? Cos square x. Now the simplification is a cos into cos square x minus derivative of cos of x is a minus sin of x, and minus minus will become plus. Therefore you will get cos square x plus sin square x upon cos square x, and the cos square x plus sin square is 1, and the 1 upon cos square x, and 1 upon cos square is sec square x. And therefore dy by dx is equals to sec square x. Derivative of tan of x is sec square x. Now next is y is equals to sec x, that is equals to 1 upon cos of x. Therefore here we will apply the result, that is a rule u upon v for the quotient rule. See this here, ddx of, that is a, here u is 1 and v is a cos x, that is a v into derivative of 1, that is the ddx of 1, derivative of 1 is 0 minus 1 into ddx of cos x upon v square, that is the cos of x bracket square, derivative of 1 is 0, 1 into, that is the cos of x into 0 minus 1 as it is, and derivative of cos of x is a minus sin x, and that minus minus will become plus upon cos square x. That is a, this will become 0 and this will become plus sin of x upon cos square x. That is a sin of x upon cos x, that is a sin x upon cos x into 1 upon cos x. Therefore you will get tan of x divided by x is equals to tan x into sec x, and that's why derivative of the tan of x is a sec x into tan x. And in this way we have completed all the exercise from the M2 for the 11th standard, and now the remaining part is that the miscellaneous exercise. Now whenever I will get the time frequently, I will continuously upload the miscellaneous exercise. Now I will, in the next video I will go to M1 for the next chapter, remaining chapter. I think that there is a circle, and after completion of all these chapters exercise, then I will take the remaining exercise. Till then there will be the 12th standard textbook will be there also. I think that in the month of the March or April, and we will start then the 12th standard. In this way we have completed the total M2, all the exercise, but till there are some problem sets are remaining. We'll see in the next video. Till then, goodbye.